My name is Liz Dvorsky. I'm a computer science major who is currently enrolled in HON260, the culminating honors project course. The title of my project is Exploring Data Compression, Pre-Processing, and Dictionary Techniques. I began reading Introduction to Data Compression in May of 2025 after Bristol purchased a license for the O'Reilly Learning Platform. A few months later, I was scrolling through Quora when I saw user Roni Alesh's question. He asked, if all digital storage is made of zeros and ones, why can't files overlap to save on capacity? Some respondents pointed out that, especially with newer file systems, things like this actually do happen on storage devices. My first thought after seeing his question was about data compression. Before the compression of multiple files takes place, the files are compiled into a single archive. Data from each file is stored sequentially. In the archive, each file is distinct. My research question for this semester was, can data compression be achieved and perhaps even improved through the overlap of contiguous files? The contract I signed for the Culminating Honors Project course is mostly about dictionary compression techniques. In keeping with my contract, the first program I wrote for the semester uses the Lempel-Ziv-Welsh algorithm. The LZW algorithm is best known for compressing pixel data and GIF images. The LZW algorithm aims to reduce file size by creating a table of strings, adding new entries as they are encountered in the file. If the string is found elsewhere, the instance is replaced by the string's entry number. If the entries were individual words in a text file, for example, the text buffalo, buffalo, orange, buffalo, orange might be coded as buffalo 1, orange 1, 2. This text is 17 characters shorter than the uncompressed version. Though my honors contract is about dictionary techniques, I began to work on my research question, which quickly deviated from the use of dictionary techniques. Inspired by bitmap and JPEG image formats, I decided to overlap the test files by interleaving their individual bytes. This did not lend itself well to dictionary compression, or at least not with the file types or in the ways that I attempted. Most of the techniques that are currently in the experimental compression method, including the interlacing step, are pre-processing techniques. They rearrange data on a byte level before the compression process takes place. I wrote small programs for the experimental method steps, including 2 that implement pre-processing techniques used in bzip2, which is a popular compression method. These are the Burrows-Wheeler transform and the move to front transform. The transforms move data around, hopefully in a way that improves compression. In the experimental pipeline, the transform programs operate on the files after they have been interleaved. After the Burrows-Wheeler transform and move to front transform, most files will have sequential 0 bytes. The 0 bytes can be collapsed with a compression technique called run length encoding. That is what happens in the last step of the experimental method. I tested the experimental compression method with 3 file types: text files, bitmap files, and PDF files. To determine whether compression was achieved, I calculated the compression ratio. The compression ratio is found by adding the size of the uncompressed files, and then dividing that sum by the size of the compressed file. A quotient greater than 1 means that the files were compressed. A result less than 1 indicates that the files expanded. To determine the experimental method's efficacy, I compared the ratios to those of 3 popular compression methods: bzip2, deflate, and LZMA. The experimental method achieved compression with all of the tested file types. With a ratio of 1.02, The compression achieved on the text files would probably not be considered worth the computation. The experimental method did well with bitmap files, but it was not as good as bzip2 or LZMA. The compression ratio for the PDF files was much higher than I expected. After the tests, which were admittedly few, I concluded that compression can be achieved after overlapping the data of contiguous files. Because steps 2 through 4 of the experimental method are a part of the bzip2 pipeline, I also concluded that interlacing does enhance compression in some cases.